Okay, this is second semester Math 7. This is Unit 2, Lesson 12 and 13. These are combined. Okay, vocabulary review. What is the height of a triangle? Who knows what the definition is for the height of a triangle? Who's got that? How do we know something's the height of a triangle? So when we went over these lessons, I said half the battle is identifying the correct parts of the figure, so you can plug it into the formula, right? So you had to understand the definition of the height of a triangle. What is it, Abu? Okay, Oren?
It's the line perpendicular to the base.
Nice. I like it, and it's exactly right. Did you guys hear what he had to say? It is the perpendicular distance. And what's it mean to be perpendicular? So it's the perpendicular distance or length from the base to the vertex of a triangle. Okay? The base, here would be the base. Okay? Oh, you forgot base. Here we go, base. Got it? All right, moving along. How do we find the area of each triangle? How do we find the area of each triangle? Tayana.
You can either have to multiply the base and the height, and then you divide it into two.
So the area of a triangle, there's a formula. Do you know the area of a triangle? What's it equal? Say it.
It was 96.
Well, the formula, yeah. So we can just use that for all the other ones. What is it?
Base times height and divided by 2.
Right. So we're going to take the base, and we're going to multiply by the height. And we're going to divide all that by 2. That's the formula. So here, my base is what?
12.
My base is 12, right? So I have my 12 meters. And then we got to multiply by my height. And what's my height? 8 meters. Okay, and we're going to divide all that by 2. And so what did you get when you multiplied all that?
I got 96, and I divided
But
it by
remember, you have 12m times 8m. So remember when we multiply units, we could use an exponent for that, right?
squared.
12, 96m squared, all divided by 2. And when we simplify that, what do we get back?
48.
48 meters squared. Okay? Did you guys get that? All right. Question. When we finish the warm-up, just like I said to Glorabelle. Now, who's got number 3? There's a couple ways to do this. Ola. So we're going to use this formula all over again. Okay. And you're saying 4 feet is the base?
Yes.
Okay. And then what's going to be my height?
3 feet.
Right. So 4 feet times the height, which is 3 feet. That's this over here. 3 feet. And then our formula says we need to divide all that by 2. Okay, so what's the result going to be?
12 divided by 2.
Yep, so this becomes 12 feet. What kind of units do we have?
Feet squared.
Right, because feet times feet is feet squared. And we're going to divide all that by 2, and so what do we get back?
6 feet squared.
Very good. 6 feet squared. So basically what that's saying is if I had 6 square feet or 6 square tiles that were a foot on each side, that's how many it would take to fill up this triangle, to cover this triangle. Do you guys understand? I might have to cut pieces to make it fit and cover every single bit of that triangle, but that's how many of those squares I would need. Do you guys understand? Okay. Now, the alternate method, you could have, did somebody have another way to think about this and solve this?
Wait, oh, for that one?
Mm-hmm. There's another method you can think about. So let me share with you another method. Actually, you know what? I'm not. Let's just stick with our basic formula. Now, I want to go ahead. What you learn to find the surface area of prisms and cylinders using nets. New vocabulary: net, surface area. Why learn this? When you wrap a birthday gift or cover a textbook, so you are working with surface area. Surface area tells you how much material you need to cover something. You can use a net to solve surface area problems. So I know we don't have textbooks here because everything's online, but a lot of students, they get checked out of textbook, and they have to return that textbook at the end of the year. And if it's you didn't take care of the textbook, guess what? You had to buy the school's textbook. So a lot of students would actually wrap their textbook in a cover to try to protect it, because nobody wanted to buy a textbook. Did anybody ever do that? Okay. So I always took a paper bag. I cut it open, right? What did you guys use to cover it? Some people use.
Book cover.
You guys bought book covers? I wasn't spending money on a book cover.
I used my book cover. They told us to bring book cover to school.
So I wasn't going to buy a book cover. I made it out of a paper bag. I would cut the bag open flat, and I'd use that to make a book cover. Some students like to make their books look pretty, so they get wrapping paper, and they'd use that. But wrapping paper is not as thick as like a paper bag. Paper bags help your books stay longer. So anyway, I wanted to make sure I wasn't going to pay for any books later in the school year when we return it. Okay, so look, a net is a two-dimensional pattern that can fold to form a three-dimensional figure. You can use nets to design boxes. Now, when they say design a box, there's more than one net that you can use to create a container, the same container. You can have a specific three-dimensional figure, and the net for that, there's no one net for it. There's a few different nets you can make for that three-dimensional figure. Does that make sense? Okay. So let's take a look at this. Do you see this, this net? And what do we get when we fold this net? What is that figure? Rectangular prism, right? Okay, and it says right here you can draw many different nets for a three-dimensional figure. Okay, there's no one way to create a net for this box, for this rectangular prism. There's more than one way to do it. Now, can I get you to draw a net for the rectangular prism at the right? For the triangular prism, excuse me. Can you draw a net for this? Go ahead and draw one. Try it. Sketch it. I'm looking around and I see kids that don't even have a notebook out. I'm pleased that most of you had it out. Thank you. Thank you. You're following directions. This isn't a difficult activity either. So when you're done, can you put your pencils down? And I'm going to show you using this figure how I drew it. But there's more than one way to draw it. Okay, there's still a few people drawing it. Okay, so there's a few of you still drawing. It doesn't have to be like perfect. It's just a sketch. I'm going to show you how I would draw it. So you would need a polygon to cover this side of my figure, right? Okay. But not only that, don't I need the same shape to cover the bottom too? Okay. And so I'm going to go ahead and then I'm going to okay, so that's going to be for my bottom of my box, all right? And so then the sides of a rectangular prism are always what?
Rectangle.
It's always going to be a rectangle. So I'm going to make a rectangle here. Okay? And so and if you notice, this goes along the bottom of my box, right? So I need to make sure these things line up. I also need one for the, what do we call this side that's opposite the legs? Hypotenuse. Good, I'm glad you guys remembered. So hypotenuse, so the hypotenuse is also the length of that rectangle on that side. And then we've also got this same height that we're using again. Okay, and then I'm going to, from that box, no, that didn't work out, did it? Okay, and so in order for me to have a net that I can fold into, I need to make sure that the edge of my rectangle lines up with my triangle, right? Okay. And then I got one more side I got to take care of, right? What side would it be? What side? What's the name of that side if I'm looking at a right triangle? I already talked about a hypotenuse. What do we call the other two sides? The legs, right? So I got this one on the back that I haven't made yet. Okay. And I'll just go ahead and draw these in. And I'm taking my time with this just because I want to show you guys that these come from the actual drawing. And so what we have here is, again, the other side of the rectangle, right? Okay, and I'm going to go ahead and say that that goes over here. Okay, and then what I can do, that's one way to draw the net, right? So if I fold this, say we're looking at this and this is flat on a table, I could fold this the sides up, right? And then I could fold this over the top as a lid, this triangle here on the left. So do you guys understand the net? Now, there's a couple ways I could have made this net. Watch, I could have made it another way. Watch this. Some of you guys might have a net that looks like this. This is the net that would give me the same box or the same rectangular prism. So let me go ahead and show you another way to look at this. So I don't know how you drew it, but I just wanted to show you that way. Now another way you could have made this net, I don't know if you did it that way, but you could have made it like this, right? Where you folded it around, these sides meet up, and then you have the top and the bottom, right? So do you understand that there's no one net for a three-dimensional figure? There's a few, right? Okay, so I'm going to go ahead and I'm going to I'm going to put my net. Did anyone have a net like that? No. But you guys understand the net once I explained it, right? Okay. All right, so here's what I want you to do. I already showed you two nets for the triangular prism. I'll just go ahead and can somebody explain to me a net that maybe I haven't shown yet? Abu, what'd you do?
You could have done, well, I made another one.
Uh-huh.
Well, actually, this is real. So,
What's that?
you could have done, this is actually me. You could have done, put two rectangles on each hypotenuse.
No, it would have just been. Oh, do you mean maybe that I could have maybe put a triangle on each hypotenuse, the hypotenuse of the triangle on the rectangle? Do you mean like this? That's another way I could have made a net. Rudy?
So what I did was I had one triangle, I put the one triangle there, and then I put rectangles on two of the sides of that one triangle, and then on the
Okay, so was it like this?
kinda, and then that last square, I put
This
that-
one at the bottom?
yeah, I put that at the bottom of the triangle,
Okay, so that means I'd have to rotate this
and then
like
I put
this.
that.
Uh-huh.
I put the last triangle on that smaller square.
On the smaller one, so it would have been upside down like this. Is this how we'd have it? Shh. So we've already seen how many nets? 3 different nets. 858. So this is how you had it? Okay, so it depends on your creativity. You could probably come up with many more, right? But these are 2 nets for the same 3-dimensional figure. Okay, so do we understand what a net is? Any questions about a net? Okay, now what I need you to do is we're going to try to calculate the surface area of a 3-dimensional figure. And the way we do that is we need to understand that the nets, the area of each of the pieces of the net is going to be the surface area for that entire 3-dimensional figure. Do you guys understand? So, what I need you to do, how do we solve this problem? We're trying to find the surface area. So we're asking ourselves, how much paper do I need to cover this 3-dimensional figure? So if we go back to the previous problem, if we knew the dimensions of this triangular prism, couldn't we find the area of the 2 triangles, the top and the bottom? And then we know how to find the area of the rectangles, right? So we'd find the area of each of these, and we'd add them up, and that's the surface area for the 3-dimensional figure. Do you guys understand? Okay. We're talking about surface area. Later we're going to talk about volume, which is something different. Okay, question.
So for each rectangle or triangle, would you calculate each area and then add them together?
Yes, so did you guys hear what Alexis said? She's trying to problem solve here. She's trying to figure out what's the total surface area. She said, so I'm going to find the area of each of the rectangles and add them up, but you're forgetting the top and the bottom, which is what? Which are the 2 triangles, right? So can you guys really quickly calculate the surface area of this triangular prism? And while you guys are doing that, I'm gonna draw each of the faces just so we can see where all the information is coming from. But you guys have all the dimensions here, so you guys should be able to calculate the surface area. What kind of triangle do we have? They're right triangles, right? Correct. And how many of them are there? Good. So keep that in mind when you're trying to calculate the areas. Questions? What's up?
Okay, so for the triangle, because I know when you were trying to find the area, you kind of have to like cut the square or rectangle in half. But since we have two triangles, would you just leave it whole instead of dividing by two?
So you're coming up with some shortcuts, right? So did you guys understand her question? She said, hey, we know the area of a triangle is half the base times height, right? But since we have two of them, I just take the base times the height, and I don't have to divide by 2, and then I have the area of both triangles. Do you guys understand what she's saying? Okay. So that's one way you could do that. Okay, I'm going to take my time with this one just to make sure that you guys... And remember, once we have the area of each of the faces, is that the surface area? Have we figured out the surface area then?
Of what?
We need to know the surface area of each of the faces of my triangle, correct?
Yes.
Okay, so... All right, I'm going to move some of these pieces around so that we can see where they are with the... If it's yours, turn it off. Okay, so now I have another one of my faces. Okay, and then I need to do the one that's 15. And that has got a height of 4. Okay, almost done. Bear with me. Okay, so do I have at least all the faces represented here? Okay. I need to copy one of my faces, right? What face do I need to copy? Okay, so let me go ahead, and we're going to take this. I'm going to move this over here. And we have this face over here, this face over here, and then there's 2 of these. So take a look. I have this face that is right here, and then I have this face that is on the back side, and then I have this face that's right here. Then I have the one that's on the top and the bottom, right? So there's two faces that are triangles, right? So who can tell me what's the area of the triangles, the 2 triangles? What was it? It's, say it again. It's 58, right? What's the area of one of the triangles? Did you say 58? 54. What's the area of one of the triangles?
Oh, the area?
Of one of the triangles.
One of the triangles. Oh, together they're 108. Exactly.
Oh, I'm sorry. I thought you were saying they were both. So could you clarify, please? What's the area of one triangle?
One triangle is 54, and the other is 54, so that adds up to 108.
So one of the area is 54. So and what's the formula for area of a triangle?
Area of the triangle is base times height divided by 2.
Okay. So we're just going to say the area of the top plus the area of the bottom. And that equaled what? What was the top and the bottom again?
Top and the bottom
Together?
together
Uh-huh.
equals 108.
108. Say again?
108. Wait, 108
Centimeters squared. You guys agree with that? Okay, so now we got to think about the side faces, right? Who's got this face that's along this leg of the right triangle? Who's got that? And I'll call this area of the side 1. Who's got that one? Alexis? 48 centimeters squared. And then what about the area of this rectangle formed along the hypotenuse of my triangle? I'll call this area side 2. Who's got that one? Caleb in the back. 60 centimeters squared. And then who's got the area of this one on the side that's along the leg of my right triangle? Anybody? Who's got that one? Tim, Jonathan, do you know what it is? What's the area of that rectangle on the side? The one that's on the side here, what is it? It's a rectangle. How do you find the area of a rectangle? Right, so we know the base and the height, right? So what's the area going to be? Base, height. It's okay. It's early. Well, what's 4 times 10? Right. So 4 times 9 would be 4 less than 4 times 10. What's 4 less than 4 times 10? No, what's 4 less than that? Take away 4 from 40. That's how you can do a quick. So this area of the side 3, hello, is going to be 36 centimeters squared. Have we found the total surface area? Yes. Now we got to find the total. So let's get the total. We have the top and the bottom, which is 108. And then we got the side that's 48 centimeters. Then we got the side that's 60 centimeters. And then the side that's 36 centimeters. We're going to add all that up. They're the same units. 8 and 8 is, plus 6 more is 22. Carry the 2. I got 2, 4, 6 plus 6 more, plus 3.
15.
Carry the 1, and then 1 and 1. 2. So the area, the total area, the surface area, the surface area for that prism equals 252 centimeters squared. All right, so I took my time on this. Saki? You know, as you get better at these, you might be able to mentally add these up. But I wanted you guys to first see that the net is how you can break this up into its pieces, right? Okay, so as you get better at understanding like how the nets relate to the three-dimensional shape, then you could take some shortcuts mentally, like Alexis had a shortcut. She said, hey, look, we know the area of the triangle is 1/2 base times height, right? But she also knows that there's 2 of them, right, for a prism. So she's like, okay, I'm just going to multiply base times height. I don't need to divide by 2 because I'm going to multiply by 2 because there's 2 of them, right? So we have a shortcut that Alexis brought up already, okay? So let's go ahead, and this is for you guys to do. A little easier. Let's go ahead and knock this one out. I'm not going to draw all the sides for this one, okay? I took my time for the first example. This one I want you guys to do. So really quickly, let's get this done. I see most students are trying to work. They're writing something down. They have a pathway to solve this. Do you not have something to write with? Actually, use this. Keep it. That's mine. Now there's definitely a few shortcuts here with this rectangular prism, right? There's a few. And it kind of goes along the lines of what Alexis was using as a shortcut earlier. So I think Saki had a good question. He said, are there any shortcuts? This one, there's definitely some shortcuts, right? Saki, did you see any shortcuts? Well, think about what we have here. We have a box, right? So Alexis, thinking about the previous problem, what would be some shortcuts you use here?
So you can, instead of just like multiplying twice and adding together, you can just do, so let's take the first.
Maybe if I drew this, Saki, maybe you'd understand where I was getting at.
Let's take the first section.
So let's take a look at this face. Do you see this face, Saki? Right? So on the back side of this, I have the same face. Okay? On a rectangular prism, how many faces do I have? Think about a dice. How many sides are on a dice? Because a dice is a cube, and a cube is a rectangular prism, right? And there are how many sides to a dice? 6. So this is a rectangular prism. Not all the sides are squares, so we can't call it a cube, but it's still a rectangular prism. And so that we know that the sides that are opposite are the same area, right? So do you understand the shortcut I'm trying to get you to think about? So I'm just going to go put this over here. And so Saki, how would I find the area of the front face, the face that's towards us? What would it be? What am I multiplying? No, that would be the bottom face. I'm talking about the face right here in front. It's 16, but what's the height going to be? 4. There you go. So we got 16 feet times 4 feet. And what do we get back? Did anybody calculate this? 64, what are the units? Feet squared. And how many of these faces do I have? I got 2 of them. So I need to add this up twice, right? Feet squared. I need to add that up twice. And then I'll have those faces. But now what I want to do, Saki, let's go and do the one that you were trying to do, the bottom face. And there's 2 of them, right? There's the one on the bottom, and then there's the one on the top. Those are congruent figures, right? So let's go ahead and calculate that. What's that going to be? What are the dimensions I'm going to use to multiply? 16 times 5. So I got 16 feet times 5 feet. And that gives me, what's the area of the bottom face and the top face going to be? 80. 80 feet squared. And there's 2 of them, so I'm going to add that up, right? Just like there's 2 of these, I'm going to add those up. All right, so let's go ahead and get this face on the side. Boom, boom. And then you guys see that there's 2 of them, right? Because I have the one on this side and the one on this side, right? Okay. And so what would the area of that one be? What am I calculating for that one? You're saying it's 20, but what was it going to be? 4 times 5. 4 feet times 5 feet equals 20 feet. So we have 2 of those faces, right? So that means for that face, the sides, the right and the left side, it's 40 altogether, right? Okay. And then for this one, we had 80 and 80, which is what? 160 feet. And then for the front and the back face, how much is that? What is it? 128 feet squared. So what's the total surface area going to be then?
328 feet.
You're going to take the two faces, 128, 160, and then 40 feet. And when we add all that up, 328 feet squared. Okay. So, any questions about that one? Surface area. Are we good? All right. Now, we got to go back to our formula that involves circles, right? Why? You guys remember what I said yesterday about opening a can with the cylinder I showed you guys? Now, some of you guys said, hey, when you open the can, you take the lid off, right? You take the top cylinder off. You take at the top of the cylinder, which is a circle. You take it off. Some of you guys leave it attached, and then you pour out what's in the can, right? You can go after her. Quickly have a seat. There's a pen right there. All right, if you cut a label from a can, you will see that the label is a rectangle. Have you guys ever turned in soup can labels for fundraisers? If you take the label off of a can and you unroll it, it's a rectangle. And the length of the rectangle is actually the circumference of the circle that makes the bases of the cylinder. Got it? So, here is an example of a net for a can or a net for a cylinder. Now, do you guys remember the formula for area of a circle? What is it, Ola?
2 radius times pi.
What is he thinking of? He's thinking about circumference. You're thinking about the distance around, right? What I need is the area of a circle. Caleb?
It's radius times pi. Wait, radius squared times pi.
So, or the book sometimes will say pi, radius squared. But remember, it's all multiply. Radius times pi, or radius squared times pi, or pi times radius squared. That's all the area of a circle, right? And then, but if you look at this rectangle, why is the length of the rectangle 2 pi r? Let's think about what I just said earlier. That's not the area. 2 pi r is what? The circumference of the top and the bottom, right? And you need the rectangle to be long enough so it will wrap around the edge of the circles that make the top and the bottom. Do you understand? And then the height of the can is just going to be the height of the rectangle. So that's an explanation of the formula for a cylinder. Let's move along. Here we go. We're going to find the surface area of a cylinder. So they're giving us some information here. Now you have to be careful because what are they giving me for the measure of the top of my can? They're giving me the diameter, right? And is the formula that Caleb just gave us, is that given in terms of diameter? No. Caleb, can you repeat the area formula for a circle again? Pi times radius squared, right? And we don't have radius, but we know how to calculate radius really easily, right? What is the radius of the base of this cylinder going to be? It's 5 centimeters, right? So let's go ahead. And what do we like to use for pi? Okay. Pi is what kind of number? Non-terminating, non-repeating, and then somebody over here said it, irrational number. Good. And we use an approximate value for pi. What's the approximate value for pi that we use? So very good. Nice. You guys remember these. 3.14, and then we said that radius is how much? It's 5 centimeters. And we're going to square it. So let's go ahead and figure out what the top and the bottom area is going to be. We got two of them, so we're going to figure out what the top area is going to be. Now, I could just go ahead and put 2, right? But let's go ahead and figure the area what the top is going to be. Let's go ahead and multiply this out. What's 5 centimeters to the second power?
25.
So we got 25 centimeters squared, and we got to multiply that by pi. Can you guys really quickly do that? Really quickly, it's 924. Next, and then 924. So who's got it? How much is it? What's the area going to be for the top of my can?
78 and 5/10.
And I like that you used the correct name. It's 78 and 5/10, but you forgot units, centimeters squared. Okay, and we have 2 of them, right? Because we got the bottom one also. So I need to multiply this by 2. So let me go ahead and double it. I can double it by multiplying by 2, or I can add the same thing to itself, right? So the bottom area is also 78 and 5/10 centimeters cubed. Let's add that together. What do we get? 157 centimeters squared. But we're missing one area, right? What area are we missing? The rectangle. And how do I find the area of this rectangle? It's the area equals the base times the height, right? And then they give me the height, right? What's the height? 14. And they're giving me the length of my rectangle, right? Isn't it another formula for the circumference of the circle? There's 2 of them I get that you guys remember the 2? What's the one that we just saw on the other screen? Somebody gave it to me for mistakenly for area. Okay, go ahead.
Radius times 2.
Times pi. So radius times 2 times pi is the circumference of a circle. But what formula do they give me right now? Diameter times pi. Remember, they're both the same formula. They're both the formula for the the circumference of a circle. So here, my base of my triangle is going to be 10 times pi. But then I got to multiply by my height, which is what? 14 centimeters. Okay, mentally we know 10 times pi. What's our approximation from pi? 3 and 1400ths. And if we multiply by 10, what's happening to my decimal? Do you remember the shortcut? Please remember the shortcut. It moves how many? 1, not 2. 10 only has 1 0. So 3 and 1400ths becomes 31 and 4/10. And then we got to multiply that by 14 centimeters. Can you do that really quickly? And this should be a length of centimeters. So I need to put a unit in here. There should be a centimeters in here. Okay, so you guys go ahead and multiply that out. So did you guys get the same thing that Abu got? Anybody got something different? Okay, now, is that my answer?
No.
How do I get my final answer? I got to add these 2 things together, right? So I got to take 439 and 6/10, and I need to add 157. And that's going to be my surface area. Quickly. Now remember when we added decimals, we line up my decimals, right? What are the units going to be?
596
Centimeters squared. Okay, we're running short on time, so this is a problem you guys need to do on your own. Let's go ahead and take a look at the last slide. The blank of a prism is the sum of the areas of its faces. The surface area Okay. What kind of polygon is included in both a net of a triangular prism and a net of a rectangular prism? And we talked about this yesterday when we had the wood models. Remember, prisms have the same shape on the sides. Do you remember that? And it's named for its bases, right? But all the prisms that we looked at yesterday had the same shape on the sides. What was that shape? A rectangle. Okay. What is the figure formed by this net on the left? Cylinder. What is this figure formed on the right? Cube. Who was thinking rectangular prism?
Me?
Okay, it is a rectangular prism, but when all the sides are squares, it is called a cube. Okay, ladies and gentlemen, I need you to make sure that you do lesson 12 and 13. Connexus breaks it into two lessons. Your quick check, you need to do those two lessons.